Now here's something interesting. Like we had learned before, stars are not usually isolated, binary or multiple, right? So, neutron are no exceptions. Some come in binary pairs. Now, if they come in binary pairs, we can actually get some of the mass, and it turns out it's 1.4 stellar masses. Okay, so now there's something called an X-ray burster, and these we found with X-ray telescopes. Basically, it's violent eruptions of X-rays. Radiation comes from these eruptions. Now, what happens here? It's brief. These X-ray eruptions just boom, there they are, and they're 1,000 times brighter than our sun. I mean, this is just incredible stuff. And then what we get to see from Earth is like before, during. Wow, looks like a bright dot that just got brighter. But it's actually X-rays that could disable our entire navigation and GPS and cellular communications and whatnot erupting from a star. And the brightness is 1,000 times brighter than our star, than our sun. Okay, so what causes these X-ray bursters? Well, again, most stars come in at least pairs, if not more, right? So, assuming that they come in a pair, the neutron star actually is going to have a lot more gravity because it's got a lot more mass than its companion. So, it's going to pull matter away from the other star. And as matter starts to pull away, it starts to create basically an accretion disk, so you can see that kind of circle of light around it. And the accretion disk gets hotter and hotter and hotter as more mass gets onto it. And so eventually it's going to be too hot and X-rays are going to pulse out from them. And so that's what we think are causing the X-ray sources. And this is going to happen kind of in a cycle, so however long it takes to build up, get too hot, and spread X-rays out. A white dwarf, a nova or supernova on a white dwarf is the exact same process. We won't be able to talk about those. I believe that's chapter 12. Don't have enough time.